Hello everybody. So in this video we continue with Chapter 6, Trigonometric Functions and Equations, specifically Section 6.4, Trigonometric Equations. We're going to start with the unit circle and exact solutions to trigonometric equations, and we're going to go into example 6.12. So it says, find the exact solutions to the equation sine of x times cosine of x equals 2 times cosine of x for the interval minus pi to pi. Solve without a GDC. This is what is called an analytical solution. So if we have sine of x times cosine of x is equal to 2 times cosine of x, the first thing you are naturally going to think about is canceling out cosine and cosine. But never do that. With trigonometric equations, if you cancel out terms like this, you are going to actually eliminate one of the solutions. So we never do that. Instead, what you want to do is group everything on one side. So notice that this is the same as sine of x times cosine of x minus 2 times cosine of x is equal to 0. Then we want to factor out cosine, and we're going to get cosine of x times sine of x minus 2 is equal to 0. And therefore we have two solutions. We have cosine of x is equal to 0. And then we have sine of x minus 2 is equal to 0, which is sine of x is equal to 2. Remember that the range of the function sine is between -1 and 1. So this exceeds that range and therefore has no solution. So we only focus on cosine of x is equal to 0. So where is cosine of x equal to 0? For this, we need to use the unit circle. So here we have to be careful with the interval. Notice that it says from minus pi to pi. So that means from minus pi, which is over here, this is minus pi, to pi, and going counterclockwise, starting at minus pi, we end up at the same point here, pi. So where is cosine of x equal to 0? Cosine of x is equal to 0 at 0, 1, or at pi halves, and also at 0, -1, which is 3 pi halves. But we have to be careful here because 3 pi halves is beyond this domain. Nevertheless, remember that this is also minus pi halves, and minus pi halves would be in this interval. So the solutions to this equation would be x equals minus pi halves and pi halves. So now we continue with example 6.13, and it says find the exact solution or solutions to the equation tangent of theta plus 1 equals 0 for the interval between 0 and 360 degrees. So whenever you have this, it means that they want the answer in degrees. So it's tangent of theta plus 1 is equal to 0, or tangent of theta is equal to -1. Now, remember that tangent is the same as sine over cosine. So where is sine over cosine equal to -1? Now, this only happens when the values for sine and cosine are the same. And remember that that happens only for angles that are 45 degrees. So just think about the special right triangle, where we have 45 and 45 for the acute angles, and we know that this side is 1, this side is 1, and this side is square root of 2. So in this case, remember that sine of 45 is equal to 1 over square root of 2, and also cosine of 45 is equal to 1 over square root of 2. So this is 45 degrees, and so is this here, right? 45 degrees. Now, If we think in terms of the unit circle, we need these to have opposite sign in order to get -1, right? So where does this happen? Where do sine and cosine have opposite sign? Well, that depends on the quadrant, right? So remember that in the first quadrant, we have plus and plus, so then tangent would be positive. In the second quadrant, we have minus and plus, so this would be one of the solutions. In the third quadrant, we have both negative, so tangent would be positive. And then in the fourth quadrant, we have plus for cosine and negative for sine. Now, that means that the solutions are going to be these two angles. 135 degrees is one solution. Remember that the reference angle is 45 degrees here from the x-axis, right? And the other solution is going to be 315 degrees, which is also 45 degrees from the x-axis, which is our reference angle. So that means that for this equation, the solutions for theta are going to be 135 degrees and 315 degrees. So we continue with example 6.14, and it says find the exact solution or solutions to the equation cosine squared of x minus pi thirds is equal to 1/2 for the interval between 0 and 2 pi. So this indicates that the solutions have to be in radians. So it's cosine squared of x minus pi thirds is equal to 1/2. Now, you have to be careful here because cosine squared, this expression means that the whole thing is squared, right? So this is the same as saying cosine of x minus pi thirds squared is equal to 1/2. So we would have to square root both sides to find the solution. So let's square root both sides. And whenever you square root something, remember that you have two solutions, plus and minus, right? So then we end up with cosine of x minus pi thirds is equal to plus minus 1 over square root of 2. Now this is the same as plus minus square root of 2 over 2. So notice that this implies that our reference angle is 45 degrees. Remember from the special right triangles that the 45-45, as we saw in the previous example, has sides 1, 1, and square root of 2. So cosine of 45 degrees, or pi fourths, is going to be square root of 2 over 2. No, but because we have plus and minus, this implies something else. But for that, let's look at the unit circle. So the first thing is to remember that this here, this angle, is pi over 4 radians. What's the x-coordinate here? Square root of 2 over 2. The y-coordinate would also be square root of 2 over 2. Then the next angle that would have square root of 2 over 2 for x, actually this would be negative square root of 2 over 2. This one would be, notice that this is 1, 2, 3, so 3, this is 3 pi fourths. So this would be the x-coordinate, which is cosine, and the y-coordinate would be square root of 2 over 2 for sine. The next angle that would have 45 degrees as a reference would be here, and this is 5 pi fourths. And for this one, we would have negative square root of 2 over 2 for x, and square root of 2 over 2 for y. And then the next one would be 7 pi fourths. And here we would have square root of 2 over 2 for x, and negative square root of 2 over 2 for y. Well, this one would be negative, by the way. In general terms, what does this imply? This implies that x minus pi thirds should equal pi fourths plus k times pi halves for some k that is an integer. So if we solve for x, we're going to get that x is equal to pi thirds plus pi fourths plus some k times pi halves. Why pi halves? Well, because all these angles have pi halves distance between them. And these are not the solutions yet, right? Because it's not x itself, but it's x minus pi thirds. So we have to solve for this. So let's do the math here. We're going to get 12. Okay, so it's going to be, this is going to be equal to, x is equal to 7 pi over 12 plus k times 6 pi over 12. So now what we have to do is test for values of k that will give us solutions that are in this interval between 0 and 2 pi. So if we do k equals 0, we're going to get 7/12 pi. And that would be one solution. If we do k equals 1, then we're going to get a solution of 13/12 pi. If we do k equals 2, then we're going to get a solution of 19/12 pi. Okay, and these three solutions are still within this domain, right? These are still less than 2 pi. But if we do k equals 3, it's going to give us 25/12 pi. And 25/12 pi is more. This is greater than 2 pi. So this is not a solution. But that doesn't mean we only have three solutions. We might have another solution. Let's test for k equals -1. So if we do k equals -1, then we're going to get pi over 12, which is obviously within the domain. Now, if we do k equals -2, then we would get a negative solution. To be exact, we would get -5/12 pi, and this is also not in the domain. So that means that we have all the possible solutions. Let's write them up here. They are going to be x equals 7/12 pi, 13/12 pi, 19/12 pi, and finally pi 12ths. So next we're going to take a look at graphical solutions to trigonometric equations. If exact solutions are not required, then a graphical solution using your GDC is a very effective way to approximate solutions to trigonometric equations. Unless instructed to do otherwise, you should give approximate solutions to an accuracy of 3 significant figures. So this would be like a paper 2 question. Notice in example 6.15, they want us to find all solutions to the equation 3 times tangent of x equals 2 cosine of x in the interval from 0 to 2 pi. So for this, we're going to use the GDC. Now, the first thing that we need to do is rearrange this equation and equal it to 0. In other words, we're going to graph 3 times tangent of x minus 2 times cosine of x is equal to 0. So that's what we're going to plug into the calculator. So we go to y equals, and there we go 3 tangent of x minus 2 cosine of x. Okay, but before we hit graph, we want to make sure we have an appropriate window. So the appropriate window would be in relation to the domain and range of this function. Now this function has tangent, so the range is all real numbers. So the range really doesn't matter here. But we do have to be careful with the domain. Notice that the domain is between 0 and 2 pi. So if we go to window, right here, notice that I'm using an x minimum of 0, and the maximum I'm going to use is 2 pi. So 2 pi. Scale should be 1. And I'm going to use a minimum for y of minus 10 and a maximum of 10 because I'm really interested only in the x-intercepts. So now we're ready to hit graph. And notice that there is our function within this domain between 0 and 2 pi. Okay, so notice that there's only 2 solutions within this domain. So we're going to find them. To do that, we go to second key, calculate on top of trace, and we want to pick option 2, 0. And then it's going to say left bound. But notice that it's on top of that second curve for tangent, but I want to go back to the first one. So for that, just scroll to the left, keep scrolling, keep scrolling, keep scrolling to the left, and it's going to appear on that first curve in a second. There it is. But because it says left bound, I want to go below the x-axis, and there I hit enter. Then it says right bound, I have to go above the x-axis, and I hit enter. And then I hit enter again when it says guess. And there's our first solution. So the first solution would be x equals 0.524. That's rounded to 3 significant figures. So now let's find the second solution. Then again, we go to second, calculate, number 2, 0. And it takes us back to the same point where we left. So now we need to go to the next curve, right? So let's go to the next curve. And we're going to appear below in a second. There it is. So left bound, hit enter. Right bound, we go above the curve to the right a little bit. Hit enter and then guess. And there's our other solution. So the next solution is 2.62 to 3 significant figures. So we continue with example 6.16, and it says the peak height h meters of ocean waves during a storm is given by the equation h equals 9 plus 4 times sine of t halves, where t is the number of hours after midnight, and then it says an alarm is triggered when the peak height goes above 12.5 meters. Find the value of t when the alarm first sounds. So again, we're going to use the GDC for this one. So let's go again to y equals, and we're going to plug in the function. So it's 9 plus 4 sine of t halves. So in this case, it doesn't really matter what the variable is, right? So x divided by 2, x halves, and then close parenthesis. So 9 plus 4 sine of x halves. Now, before we graph this, we have to make sure we have an appropriate window. And like I said before, it has to do with domain and range. So let's start talking about the domain. Well, t, because it starts at midnight, let's call that 0. So between 0 and 24 hours. So we could use that for the x. And then the range for h, from what we know about the sine function, this one has an amplitude of 4. So an amplitude of 4 plus 9, that would be 13. So let's make it 15 at the top. 15, and let's say negative 15 at the bottom, just to be sure. So this would be our domain and range, and therefore the window we would need to graph this function appropriately. Now notice that the other thing what we have to graph is the function y equals 12.5. Let's write 12.5, y equals 12.5 as well. And now let's go check the window. So the window we said is going to be from 0 to 24 hours for x. The scale is 1, that's fine. Minus 15, and then 15. So once we have the appropriate window, we can graph. Okay, so we can see the point where these graphs intercept the first time. So I'm going to make the window a little bit smaller so I can have a better look at this. Now the minimum for x is 0, but let's make the maximum a little closer, half of that, 12. And then we can make the y minimum 0. And let's see if we get a better look. And there it is. So what we want to do is find where those two lines intersect. So we're going to go second, calculate, and number 5, intersect. And then it's going to say first curve, but I want to move this cursor to the left of the intersection. So first curve will be that one, hit enter. And the second curve, it immediately jumps on the other curve and say yes. And then guess, and there it is. Notice that it happens at x equals 2.13. So that's when the alarm would be triggered the first time. So we would say to answer this at t equals 2.13 hours. So we're going to continue looking at analytic solutions to trigonometric equations. Remember that analytic means exact solutions by hand. So it says in example 6.17, solve 2 times sine squared of x plus sine of x equals 0 for the interval between 0 and 2 pi. So we have 2 sine squared of x plus sine of x equals 0. So here you always want to factor out. So it's going to be sine of x times 2 times sine of x plus 1 is equal to 0. So this particular equation would have two solutions. One would be sine of x equals 0, and the other one is sine of x equals negative 1/2. So solving this is easy because we know where sine is equal to 0 in the unit circle between 0 and 2 pi. This is going to be x equals 0 and x equals pi. Now this one requires a little more analysis. 1/2. So what is our reference triangle for 1/2? Well, if you recall, it's the 30-60. Now, in terms of radians, this would be, let's say, pi sixths, which is 30 degrees, and this one would be pi thirds, or 60 degrees. So in the 30-60, remember that 1 is opposite the smallest angle, 2 is the hypotenuse, and square root of 3 is opposite 60 degrees. So it means that sine of pi over 6 is equal to 1/2. So this is our reference angle. But notice that we have to look for the solutions that are negative 1/2. So let's take a look at the unit circle. So remember that sine is equal to 0 at 0 radians and pi radians. And then where is sine equal to negative 1/2? Well, sine is negative below the x-axis. So that means that our solutions would be in the third and fourth quadrants. And the solutions have to be 30 degrees or pi sixths away from the x-axis. So notice that this first solution is pi over 6 radians after the x-axis. So pi plus pi over 6 is 7 pi over 6. So x equals 7 pi over 6 is one solution, and the other one would be this one, also 30 degrees or pi sixth radians from the x-axis. So 2 pi minus pi over 6 is 11 pi over 6. So that's the other solution, 11 pi over 6. So we will end this video by doing example 6.18, and it says solve 3 times cosine of x plus cotangent of x equals 0 for the interval for x between 0 and 2 pi. So they want us to solve 3 times cosine of x plus cotangent of x equals 0. Now here we have cotangent. But for our convenience, we always want to express everything in terms of sine and cosine. So this is the same as saying 3 times cosine of x plus cosine of x over sine of x is equal to 0. So we're going to want to multiply both sides of this equation by sine of x. So we're going to get 3 times cosine of x times sine of x plus cosine of x is equal to 0. Then we factor out cosine, and we have cosine of x times 3 sine of x plus 1 is equal to 0. So this equation in particular would have solutions cosine of x equals 0 and sine of x equals minus 1/3. So this one to the left is easy to solve in this interval between 0 and 2 pi, because we know that cosine is 0 at x equals pi halves and at 3 pi halves in this interval. But this one is not possible to solve analytically because we don't have any reference triangles for this. Remember that we only use the 45-45 and the 30-60. So for this, we're going to need to use the GDC. So first we go to y equals, and we plug in sine of x. So sine of x and minus 1/3, minus 1/3. But then again, before graphing this, we want to make sure that we have the right window. So what would be a good domain for this one? The domain could be right here between 0 and 2 pi. So window, x will go from 0 to 2 pi. So 2 pi. And then the range of the sine function is normally between -1 and 1. But let's use -2 and 2 just to have a little bit of a bigger window. So now we're ready to graph. And notice that we will have two solutions for this equation in that interval. So to find them, let's go to second, calculate, and then number 5, intersect. And it says first curve, enter, second curve, enter, enter again, and there's our first solution, 3.48. Now this is to 3 significant figures, right? So x equals approximately 3.48. And then we need another solution. So we go again to second, calculate, and number 5, intersect. But this time we want to move to the right a little bit. And right there. So enter, first curve, or second curve, and guess. And there it is. So the other solution is going to be to 3 significant figures, 5.94.